कोड। आज हम डिस्कस करेंगे CNN और केरास के बारे में, जो कि बहुत ही बेसिक लेवल पे होगा। तो जो भी बिगिनर्स हैं उनके लिए ये ट्यूटोरियल वीडियो काफ़ी सही रहेगा, बिकॉज इसमें हम डीप में नहीं जाएंगे। सिर्फ एक बेसिक न्यूरल नेटवर्क हम CNN हम बनाएंगे केरास लाइब्रेरी का यूज़ करके, और डिस्कस करेंगे कि व्हाट आर द डिफरेंट कंपोनेंट्स ऑफ अ CNN नेटवर्क। तो लेट्स बिगिन। सो CNN का फुल फॉर्म होता है कॉन्वोल्यूशनल न्यूरल नेटवर्क। और ये जो न्यूरल नेटवर्क है ये बेसिकली मोस्टली इमेजेस के साथ यूज़ किया जाता है। तो जो भी इमेज क्लासिफिकेशन या इमेज से रिलेटेड जो भी मशीन लर्निंग या डीप लर्निंग के प्रॉब्लम्स होते हैं उसमें हम CNN यूज़ करते हैं। तो CNN में बेसिकली प्राइमरीली तीन चार टाइप्स के ही लेयर्स यूज होते हैं, जिसमें से फर्स्ट होता है कॉन 2D लेयर, दूसरे का नाम है मैक्स पूलिंग 2D लेयर, और होता है एक फ्लैटन लेयर, एंड द फोर्थ टाइप इज डेंस लेयर। ओके, dense layer. So these are the four types of layers used in a convolutional neural network. अभी हम वन बाय वन डिस्कस करते हैं कि कॉन 2D इमेज कॉन 2D लेयर का बेसिकली क्या करता है। सो लेट मी फर्स्ट एक्सप्लेन कि इसके पैरामीटर्स क्या होते हैं। तो कॉन 2D लेयर में हम पास करते हैं आउटपुट डेप्थ एंड शेप ऑफ फिल्टर। ओके, ये प्राइमरीली ये दो पैरामीटर्स पास होते हैं कॉन 2D लेयर में। और भी पैरामीटर्स हो सकते हैं, उसके लिए आप कॉन 2D का यू कैन सी द डॉक्यूमेंटेशन, बट प्राइमरीली ये दो काफ़ी इंपॉर्टेंट पैरामीटर्स है जो हम पास करते हैं। तो आउटपुट डेप्थ क्या होता है, लेट्स अंडरस्टैंड। तो जो भी एक इमेज हम पास करते हैं एज एन इनपुट, फीड करते हैं कॉन 2D लेयर में, उसके बाद जो उसका आउटपुट आना चाहिए वो आउटपुट का डेप्थ क्या होगा, दिस डेप्थ, this is decided by this parameter, output depth parameter. और ये basically this is also equal to the number of filters which we will be using. Okay, the number of filters which we'll be using for, sorry, in the in this con 2D in con 2D network, sorry, con 2D layer. So suppose output depth 3 है, तो we will be using 3 filters basically. And shape of filter is what? The width and height, width and height of filter, of वन फिल्टर और ईच फिल्टर, राइट। तो ये सभी फिल्टर्स का डायमेंशन सेम होता है, विड्थ हाइट एंड डेप्थ भी सेम होता है। द डेप्थ ऑफ दीज फिल्टर्स इज इक्वल टू द डेप्थ ऑफ द इनपुट इमेज, ओके, और द इनपुट फीचर मैप। तो जो भी इसका डेप्थ है वो इसके डेप्थ के बराबर होता है, इक्वल होता है, ठीक है। और जो इसका विड्थ एंड हाइट है वो बाई कन्वेंशन अभी इंडस्ट्री और एकेडमिया में जो यूज होता है वो होता है 3,3। सो ये हमारे फिल्टर का साइज हो गया 3,3 इंटू द डेप्थ ऑफ इनपुट इमेज और इनपुट फीचर मैप। और जो आउटपुट है दैट डिपेंड्स ऑन द नंबर ऑफ फिल्टर्स विच वी आर यूजिंग। ओके, नंबर ऑफ फिल्टर्स एंड द width and height of the output depends on the dimension of the filter and the dimension of input image. तो इसका एक formula है, standard formula which you can understand, which I will explain in a separate video. But अभी के लिए we will understand, we'll just have a high level understanding that the width and height of the output image or the output feature map depends on the width and height of filter and the width and height of input image. And the dimension, or sorry, the depth is equal to the output depth mentioned in the parameter of con 2D layer. Or shape of filter, as I told, 3,3 is the mostly used shape of the filter in industry as well as academia. ये बहुत ही research करने के बाद the scientists and the researchers have come down, boiled down to this value, because ये first of all optimum है in terms of the training time, or it can also help to g- get the features, extract the features from the input feature map. So that is why 3 comma 3 filter size is preferred. But you can use some other size also, 5 cross 5 or 1 cross 1, 7 cross 7. But usually use some odd number as the shape of the filter, because odd number से क्या होता है, सिमेट्री रहती है. Symmetry means suppose this is 3 comma 3 size, right? So this is the center pixel, right? Of this 3 comma 3 filter. But suppose if we take a 4 comma 4, then you don't have a center pixel, right? You do not have a center pixel for this filter. So it's three, whenever we use a odd size, you wanna use an odd size filter, we have a center pixel. और उसकी क्या importance है, that I'll explain in some other video. But for timing, you understand that you have to always use an odd shaped filter, and preferably 3 comma 3, 3 cross 3. So this is what is a con 2D layer. Now let's move ahead to max pooling 2D layer. Max pooling 2D layer में primarily we just feed in the uh, width and height of the pooling window. So basically, and by convention, what the preferred value for this is 2 comma 2. Okay, 2 comma 2. तो इससे क्या होता है, जो भी हमारा इनपुट फीचर है, suppose its width is w into h, जब when we pass it to a max pooling layer, the output which we get is w by 2 into h by 2. Okay, so max pooling से क्या हो के दो फायदे हैं. There are two advantages or the merits of using a max pooling layer. First is dimensionality reduction. Okay, we are reducing the dimension here, right? And it helps for faster training also. So first is dimensionality reduction, and the second advantage is we in a window of 2 comma 2, in each window of 2 comma 2 in the input feature map, this max pooling layer, what it does is it takes out the maximum value in that window. So whichever pixel has the maximum value, that we take and put it in our output feature map. तो यहाँ से we have taken this value, यहाँ से suppose from this window we take this value and we put it here, and from here we took the maximum value and we put it here, right? So this helps to basically identify the prominent features. जहाँ पे भी पिक्सल वैल्यू हाईएस्ट है, राइट? पिक्सल वैल्यू हाईएस्ट है विंडो, इस विंडो के अंदर 2,2 विंडो के अंदर, इट मींस कि वो फीचर इज मोर प्रोमिनेंट एज कंपेयर टू अदर features in that window, right? So that is why we take the max value and put it in our output feature map, right? So this is what max pooling layer does. Now let's move ahead to the flatten layer. The next is flatten layer. Flatten layer. So this basically is used to convert a n-dimensional input to a one-dimensional input. So basically it converts your whatever input we provide, right? N-dimensional input, it converts it into a vector. That's it. This is the use of flattening layer. It is basically used towards the end of the neural network to flatten out the input feature map so that we can pass it to dense layer. Okay. Now let's see what is a dense layer. I'll explain thoroughly about each of these layers in some other video. In this video, we'll just touch upon each layer and just move ahead. So next is dense layer. Dense layer is basically similar to fully connected layer. ओके, तो फ्लैटन लेयर से हम जो इनपुट फीचर मैप है उसको वन डायमेंशनल इनपुट में कन्वर्ट कर देते हैं, तो एक हमारे पास वेक्टर आ जाता है, मिल जाता है. वी पास इट टू द डेंस लेयर. ओके, एंड डेंस लेयर में व्हाट आर द पैरामीटर्स व्हिच वी हैव? The main parameters which we have in dense layer is the number of neurons in the layer, comma the activation function. Okay, activation function. So these are the two parameters which we pass to a dense layer. Okay, the number of neurons, again, it depends on the use case and activation function, right? So let's talk about activation function. So whenever there are two cases now. Number one is this dense layer is a hidden layer. Okay, hidden dense layer. Or and the second case is output dense layer. Hidden dense layer means this dense layer is somewhere in between of the neural network. This is not the output layer. And output dense layer means this dense layer is the output, like whatever the output is provided by this dense layer, this is consumed to compute the loss, or to basically or whatever other requirement is there. So basically this is the final output provided by this dense layer. So this is the second case. So whenever the dense layer is hidden, the activation function which we use is ReLU function. So in some other video, I'll explain in deep about ReLU, but for timing, you can understand that in academia as well as industry, ReLU function is the mostly preferred activation function for a hidden layer. जब output dense layer होता है output में, we can have different types of activation function like sigmoid or softmax. So sigmoid is used when we have to classify the input into two classes. Okay, class 0 and class 1. softmax activation function हम तब use करते हैं जब हमारे पास more than one class होता है, right? 0 1 2 3, we have n classes. So the output which we get from softmax function is basically probability that the input belongs to a certain class, right? For example, जो हमारा इनपुट है इट बिलोंग्स टू क्लास 0, इसकी प्रोबेबिलिटी है सपोज 0.25, क्लास 1 में बिलोंग करने की प्रोबेबिलिटी है सपोज 0.5, क्लास 2 में बिलोंग करने की प्रोबेबिलिटी है सपोज 0.3. So these are the probabilities which are given as produced as output from the softmax layer. And the same is true with sigmoid layer also, but we basically convert into 0 and 1. So 0 belongs to uh, first class and 1 belongs to um, second class, right? So this will I will explain about the activation functions in some other video in detail. For time being, you can just have this high level understanding. तो ये हमारे layers हो गए. These are the layers which are there in a CNN. अभी CNN का let's understand CNN का आर्किटेक्चर इन जनरल कैसा होता है. दिस इज नॉट अ फिक्स फॉर्मेट विच आई एम एक्सप्लेनिंग, बट इन जनरल दिस इज दिस इज द आर्किटेक्चर ऑफ अ CNN नेटवर्क. तो एक इनपुट होता है, इनपुट इमेज वी पास टू आवर CNN नेटवर्क. फर्स्ट लेयर इज ऑलवेज कॉन 2D लेयर. ओके, and we have alternating max pooling 2D and con 2D layers in CNN. Okay, max pooling 2D and con 2D layers ये alternate फैशन में होते हैं. बेसिकली ये alternate फैशन में क्यों होते हैं, आई विल एक्सप्लेन यू. कॉन 2D लेयर से वी एक्सट्रैक्ट द फीचर्स, राइट? और से नॉट एक्सट्रैक्ट, वी लर्न पैटर्न्स, यू कैन से वी लर्न पैटर्न्स, एंड उसके बाद से में हम मैक्स पूलिंग 2D लेयर में वी एक्सट्रैक्ट द प्रोमिनेंट फीचर. तो ये जो है हमारा इस फैशन में चलते रहता है. We can have n number of con 2D and max pooling 2D layers alternatively, depends on the use case. हमारा use case क्या है, what is the data and what is the output which we desire. तो ये हमारा हो गया initially. So input image we provided to con 2D, then to max pooling, then to con 2D, then to max pooling, and after we are done with feature extraction, we pass it to a flattened layer. Flattened layer basically, as I explained, converts this input to whatever input is here, an n-dimensional input, it converts it to a vector. Now we pass it to a dense layer. Dense layer जो fully connected layer होता है. There can be one or more dense layer depending upon the requirement, and finally we have the output dense layer. Okay, इसका activation can be ReLU, and इसका activation is can be sigmoid or softmax. So this is the high level architecture of a CNN network. Abhi, I'll just explain you. I'll just ex so this is the high level. So this is the high level architecture of a CNN network. Now I'll explain you how to build it in Keras. तो Keras का हम यूज करके Keras is a library, deep learning library, which is widely used for developing neural networks and deep learning solutions, and it's very easy to use. तो इसमें I'll just explain you how to just build this a simple CNN using Keras. So I'm using Kaggle for this. You can also use Kaggle for practicing and learning machine learning and deep learning. So first I'm importing the layers. So there are multiple types of layers in Keras. So that's why we need this module. And then I'm importing the models. Now I'm creating a model called model. I've named it as model, and it will be a sequential model. So there are different types of models. You can see here the different types of models, right? LSTM, separable, con 1D and 2D and all, so on and so forth, RNN models. So we'll just use a sequential model here. It's a simple model, so just for explanation, you can understand. You can go through the other types of models also, or I will explain them in some future video. Definitely. You can comment in the comment section if you want my help, need my help for understanding any of the concepts which you are struggling with. So, okay, let's move on. So, sorry, this will be models, right? I missed. It's my mistake here. I'm sorry. So, layers dot. What do we have? Con 2D, con 2D, and what the first parameter is the depth, right? So, suppose we want the depth to be 32 comma 32, and as I explained, the filter size by default should be 3 comma 3. And in the first contour layer we should provide the input shape. So this is basically the shape of the input image which we are providing. It can be anything. For just for this example, I've just considered it to be 28 comma 28 comma 1. So this is our contour layer. We can just put activation as ReLU, or even it's so now we'll have a max pooling 2D layer. So as I mentioned, it's by default, by convention, not by default, by convention, its size has to be 2 comma 2. Now we again have a contour layer 3 comma 3, and activation equal to ReLU. Now we have again a contour layer. It should be a max pooling 2D, so it has to be alternative. Now I can provide the output of this max pooling 2D layer to a flatten layer. It doesn't need any parameter. Now we'll have a dense layer, internal dense layer, hidden dense layer. Let's suppose we have here 128 neurons, and what else do we need to pass here? Activation function, right? activation, relu, and now I'm adding the output dense layer. So if it is softmax, we can have more than 10, more than two neurons. Or if it is a sigmoid, then we will have uh, just one neuron. So suppose we are using a softmax activation. So let's say I will have five neurons in the output layer, and activation is equal to softmax. So this is our model, and we'll just print the summary of the model using this command. Let's run this code. Yeah, so this is the model summary printed. The con 2D layer, this is the first con 2D layer, right? The parameters is the output shape is 26 comma 26 comma 32. Parameters is 320. Max pooling 2D basically now you here you can see, right, the output shape is reduced to half. So 26 by 2 is 13. 26 by 2 is 13. The depth remains same. Then we again pass it to contour-D. The output of it is 11 comma 11 comma 64. Here you can see the shape is reduced by 2. The width and height is reduced by 2. That is because we have used the filter. So how does the filter work? I'll explain in some other video. But this for time being, you can understand that the size is reduced because of the filter which we use in a contour layer. So and the depth is what? Depth is what we mentioned here, 64. The same is the depth here. Again, the max pooling 2D layer reduced the dimension by 2 by half. So 11 by 2 is 5 integer, right? 11 by 2 floor value is 5. This is also 5, and the depth is 64. Now we pass it to flatten layer. Flatten layer basically what does it do? 5 into 5 into 64. We get a 1D vector. It flattens this particular input feature map to a 1D vector. Now we have a dense layer of size 128. Activation is ReLU, and then we pass it to a dense layer of size 5. Number of neurons is 5. Activation is softmax. So yeah, and so this is all about Keras and CNN on a high level. Let me know in the comment section if you need my help, or you want me to make video on a certain topic. So that's all for today's video. Thank you so much. If you like the video, please subscribe to my channel. Thanks again.